install Anaconda successfully, and today we'll look at some. Actually, I have already uploaded this Python basics in your directory, whatever I shared you. There will be a Python directory that will be visible now, and in that you'll see Python basics 1. And this is the first part of the basics. So today we'll try to see if possible, we'll try to explore some of this. Okay. So download this and keep it in some directory so that when we are starting on Python coding, we'll try to open from Jupyter notebooks. We'll see that as the second part of the class. Okay, now, so yesterday we started with probability, which is nothing but likelihood of achieving something. Then we also discussed about what is an experiment, how to identify the sample space, all those things. So here, in my earlier days of my probability uh, lessons, initially I used to think, why is that throwing a die is very important. I mean, what purpose does it solve? So turns out that it's not about just the dice problem that we are interested in probability. If it is the only die throwing problem, then probably probability is not that much useful at all. But the question is not just throwing a die. Die is just a simulation of what you do in reality. So in reality, let's say application of it is directly this kind of a weather prediction, where the weather department or the meteorological department, they go and collect lot of data around let's say uh, the humidity, the precipitation, all those different metrics they'll go and collect, and based on that they'll do some prediction, and that prediction they'll associate with some probability and say that this prediction will work at this percentage of with this chance. So always probability is useful, but to simulate at a small scale, one good example is the die, throwing die, a pair of dice or something, or picking a card from a deck of cards. So all these are the real world simulation of what happens for a bigger problems. I hope you get what I'm saying. So this is the reason why throwing a die is important. It's not because of its practical application. It's because understanding how probability works at a smaller scale is very important to apply it at a larger scale. It's more like you're doing a real world simulation of a smaller piece of data. Then you apply the same concept to the bigger real world problems. Hope this helps why we always talk about throwing a die than talking about weather prediction when anyone talks about probability. Because when we are talking about weather prediction, it has a lot of variables, lot of data and all. So understanding at that scale is very difficult. So that's what I wanted to mention. If someone thinks about why always dice or deck of cards, whichever is that. So then we talked about sample space, which is nothing but the set of outcomes, all the set of outcomes, all the possible outcomes that are possible for an experiment. You keep it as a set, and that set is called sample space. So then within that sample space, what is the thing that you are interested in? So that is called event space. And event space could also be a set. It's not a single, it may not be always a single element. So that's why I gave this example of sunny, misty, and cloudy. These are the possibilities that you're interested in when you're when you want to conduct a match, a baseball match, or anything. Then I talked about probability is defined as number of events by number of sample space. That way you can get easily the probability. And we talked about getting some rolling a dice, how to get the probabilities, all those things. So then there is something called collectively exhaustive. And this collectively exhaustive is something like if you have two different events from the same sample space and the probabilities add up to 1, then it is called collectively exhaustive. So that's what we talked about yesterday. So today we will continue some discussion on probability. And like we did yesterday, we'll stop at some point, go back to Python, and do some Python coding. The idea is many people find probability very dry subject, so I wanted to take this as an opportunity, and I want to discuss some Python coding as well, so you'll not get too much bored about Python, sorry, probability. Okay, now let's continue. Any questions on whatever I covered till now?
I'm good, Sandeep.
Okay. Okay, we will take some card problems.
Sandeep, just one question. In
Sure.
terms of terminology, right, we call it the sample set. We also call it the probability to the sample set as collectively exhaustive. Is there any reason behind it, or are you going to use it in future for a different purpose?
Collectively exhaustive is something like, let's say.
Well, you can easily call it, see, for example, the probability of 1 through 6 being all the 6 elements of a particular sample space as collectively exhaustive. Right?
Mm-hmm.
Well, is there a reason you're setting the stage for a future use of this particular terminology?
Okay, so collectively exhaustive, the idea is, what is the total probability? 1, right?
Yeah.
If you are having some part of the data in maybe 75% probability, what is the remaining probability? 25%.
Yeah.
So let's say this is for your prediction is 75% right,
Okay.
25% wrong. Are they collectively exhaustive?
No, they're not.
They are, right? They are
No.
collectively exhaustive.
But yeah, if looked at from an individual perspective, 75% they're not collectively exhaustive. But looked in total, yes, they're collectively exhaustive.
Yeah, I'm talking about total.
Okay, total, yes, yeah.
I'm talking about total. So
yes.
when you are covering your analysis, you have to be collectively exhaustive, right? All the data has to be going through some buckets.
Okay.
Either it is you're doing correct analysis or wrong analysis. Let's say here it is correct, and all this 25% is wrong.
Yeah.
To be collectively exhaustive to complete your analysis.
Okay, got it.
So it's not something that I'll teach in future, but it's something that you have to remember always.
Okay.
Whenever you do your analysis, this is something that you should always take care of.
Okay. Thanks, Sandeep.
Sure, no problem. So we'll solve some card problems. Again, the purpose of using these cards and die problems and all is only for you to understand the concepts of probability, but not, if you ask me where is it really used, there is no answer. The only answer is for you to understand. This is a best way. So we'll try to solve some card problems now. Normally I'll just deck of cards. Normally I'll just keep a picture of deck of cards. That way you can easily solve the problems. Okay. Something else is opening up. Okay, I have it here. Let me import here. Okay. Downloads, and I need to see cards here. Okay. So basically, I like this method of presenting the cards because everything will be visually available, so that for you don't have to imagine everything. So we'll take some card problems and try to solve. But before that, we'll let me give you an introduction of what these cards are and how it. I mean some terminology about the cards. So each card will have so a deck of cards. These are a deck of cards, and each deck will have 4 sets. If you see every row here, every row is having a different symbol. So all the cards of same symbol are called a suit. Correct? I think it is suit. Yeah. And then each suit will have 13 cards, and you can see it starts with A. It's not doesn't start with 1. It's called ace, and it continues until 10, and then there will be J, Q, and K. So these cards will have picture on them, J, Q, and K, and the other cards will have some numbers or ace. So that's how each deck will look like. And the first symbol, when you see this is called club. The second one is called spade. This is called heart, and the last one is diamond. And another thing is spade and club. The first one is club, and second one is spade. Spade and club are in black color, and remaining two, which is heart and diamond, both are in red. Okay, so based on this, we'll have some problems, and we'll try to solve how we'll try to see how this probability definitions work, especially to calculate the simple probabilities. So we'll see some problems, then I'll ask one of you to solve these problems. So first thing is probability of getting a 2. So how much is the probability of getting a 2 from a deck of cards? Actually, I should write from a deck of cards, but it is implicit because we are in the cards problem, the section. So that's why I'm not writing probability of getting a 2 in a deck of cards. I'm not writing that in a deck of cards. It's redundant. Now getting a 2 in this entire set of cards, how to solve? Let me show you in 1 or 2 examples. Then I'll try to ask each one of you. So in this entire set of cards, what is the sample space? Sample space is the entire set of possibilities that I can get. When I am getting only one card, what is the set of possibilities? It is 52 cards. So 52 possibilities I have for getting the cards. So my sample space is 52. All the set of cards. Now in that, getting a 2, you have to go and count how many 2s are there in this entire set and entire deck. So there are 4 2s you can see. So that is your events. So what is an event? Event is a set of event is a set of your interests. So here the event is getting a 2. So you have 1 2 3 4 possibilities of getting a 2. So your probability is n of e by n of s. N of e is nothing but number of elements in the event. So you have 4 events here, and total sample space is the entire deck of cards, which means it is 52. So 4 by 52. Is everyone clear with this? It should be very easy now.
Yes, Sandeep.
Vijaya, are you able to connect what I said?
Yes, with the pictures is much more clearer.
Yeah. And Subbu and Zahir, are you also clear?
I'm fine, Sandeep.
Cool.
Thanks, Sandeep.
Yeah. Okay. Now again, we'll try another problem. Probability of getting an even numbered card. Now in this case, when I say numbered card, A is not a numbered card. Only 2 to 10 are numbered cards. And again, J, Q, K are not numbered. Now in this case, if someone asks you what is the probability of getting even numbered card, again, the same case, you start with the sample space. You have again 52 cards. So the sample space will be 52. The denominator will be 52. And now you have to go and count how many even numbered cards are there. So in a suit, in one row, you'll have 2, 4, 6, 8, 10, which means 5. 2, 4, 6, 8, 10. So there are 5 in a suit. Then in that, in the entire deck, you'll have 4 suits are there. So 4 into 5, 20. You'll see 20 cards which are even numbered. So the numerator will become 20. Okay. If everyone is clear now, I'm going to ask you questions now on this. So be ready for that. Let me call Subbu.
Yes, Sandeep.
Yeah. So you are going to answer this question now. By the way, are you clear on this too?
Yes.
So, okay. Probability of getting a picture card. Again, picture cards are only JQK. You can go here and answer based on this.
3 into 4 by 52.
Yeah, 3 because it is every suit has 3. And likewise, you have 4 sets, 3 into 4, which is 12. Or let me write the way you said, 3 into 4 by 52, which is 12 by 52. Sorry, 52. Good. Then I'll ask maybe Abid.
Yes, Sandeep.
Yeah, you're going to answer this question now. Probability of getting a red card. How do you solve that?
Okay. 20 by 52.
Sorry?
20 by 52.
So how many red cards are there?
20. Oh, 26 cards. 26 by
26.
52.
Yeah, 26. Every row is having 13, mind you. This
Yes,
is 13 cards and you have two such rows. So it is 26. 26 by 52. That's right. Now, Vijay?
Yes.
Yeah. So let me ask you probability of getting a diamond.
Thirteen by 52.
Yeah, that's right. Thank you. You're right. Yeah. 13 by 52 because one row is having 13. Now, Zahir. Now your question is probability of getting a numbered card. Well, what it means is when I say numbered card with which is having a number on it.
Yeah. It's 36 by 52.
Yeah. The reason is again every row is having 9 cards which are numbered, and you are having 4 such rows. So 9 into 4, 36. 9 into 4 by 52, which is nothing but 36 by 52. That's right. Thanks. So these are different ways of getting, a probability for different card problems. Now, the problem could be a little complicated as well. I'm little bit increasing the complexity. So in this case, I can use, in set theory, I have mentioned how to use union and intersection, right? So I can also use this kind of a union or intersection kind of a thing and try to formulate the problems also. So let me give you an example. So probability of getting a picture, when I say picture card, intersection, getting a, let's say red card. Now I'm using an intersection, but don't fret. It's as simple as getting a combination of, what are the common elements? When I say intersection, it's all about getting a common elements. So let's see what is a picture card as well as getting red card. So if you see the picture cards, this entire section is having all the picture cards which are having some picture. Okay, now that is one part of the set. You're having two sets here. When you do intersection, what you mean is this is one set and this is another set. You are doing an intersection, common elements out of them. So getting a picture card means all these things, and getting a red card, when you say red card, all the red cards are here in this direction. Now what are the common elements? Only these 6. Out of this set as well as this set, there are only 6 elements which are part of both the sets. So when you do an intersection, all you mean is I am talking about the common elements of both the sets. Now in this case, the common elements are these 6 elements. So my probability will become 6 by 52. Are you clear on this kind of a problem?
Yes, Sandeep.
Okay, cool.
Yes, Sandeep.
Let me remove this whole thing so that the image will look good at least. So that's how you do the card problems. Let me give you one more puzzle and stop this part of the discussion here. So let me ask you, anyone can answer now, whoever is quick enough. I want the fastest student first. So in this case, my question is probability of getting an even number intersection getting a black card. How many are there?
10 by 52.
10 by 52. How is that? You should answer how also. No.
So all the even numbers, there are 5 cards per suit.
Mhm.
And that's a total numerator. Then you have 2 suites that are in black.
Okay. Yeah, that's right. 2 into 5. 10 by 52. Okay. Hope you get what I was saying. So let me give you another interesting example. Getting a numbered card intersection getting a queen. Queen is Q. Queen is Q. So getting an even number, numbered card intersection getting a Q. How much is that?
0.
0. Because there is no intersection. All the numbered cards are here. And all the Qs are here. Is there any intersection? Is there any common element? Nothing. So it's 0. Probability could be 0. So here it is 0 by 52, which is nothing but 0. Is that clear? What I was saying, all of this?
Yes, sir.
Okay, let me give one more example, final, the last 10th one. Getting a diamond. Now in this case, instead of intersection, I am trying to use union. Union. Getting a black card. How much it is? Now it is union. Do not take the common elements now. Getting a diamond intersection, getting a black card. Is that what I wrote? Yeah.
Union. Sandeep.
Union. Sorry. Getting a black card. Getting a diamond union. Getting a black card.
39 by 52.
39 by 52. Because here, this is a black card set, and this is a diamond set. And here there are no common elements, but you should not take the common elements because it is a union. You should add up all these things. Here how many are there, plus here how many are there. Based on that, you add up both of them and then say it is 39 by 52. Here there are 26 plus 13, 39. Hope you are getting used to probability now. Remove this.
Yes, Sandeep.
Yes, sir.
So that is about the simple probability problems. But there are a few more things that we need to discuss before we close on the probability. So for that, we need more theory on probability. Let's go into that. And that is called conditional probability. I like the card problems because there are multiple ways I can frame the question. That is the reason I took this. And it's very easy for you to understand from this picture. So conditional probability. So let me give you the formula. I'll show you how to use it later and after giving the formula. So this is read as probability of A given B, and it is shown as, it can be rewritten as probability of A intersection B by probability of B. So this is one way of formulating the this kind of a probability, and this probability is called conditional probability. When I say conditional probability, the condition here is on B. What I am saying here is probability of A given that you already know that B is present. So in most of the problems, many times you know that some part of the problem is already known to you. You know that there is something available to you. Based on whatever is available to you, now you're asking what is the probability of getting A. So this is called prior probability. The reason for calling prior probability is that you already know that B exists. I'll show you in the problems how B exists. But for now, if you have some information regarding some problem, your probability increases basically. That is the reason when I say given B, if you know some of the things, your probability will increase. I'll show how to do those things. Similarly, if I do probability of B given A instead of A given B, I can use the same formula, but here it is B intersection A by probability of A. But actually, A intersection B is equal to B intersection, sorry, let me write it properly. A intersection B is equal to B intersection A. So here I can write, instead of probability of B intersection A, I can write A intersection B by probability of A. So here if you see both of these formulas, the numerator is same, the denominator will come based on whatever is given. Here B is given, so it is probability of B. Here A is given, so denominator is probability of A. So this is called conditional probability, and this is one of the most important concepts in probability. In fact, using this and this alone, I can use a machine learning algorithm. It's as powerful as that. And we'll see the machine learning aspect in the later part of the course. But right now we are only considering probability, conditional probability.
Hello.
Yeah.
Can you please explain this last point, A intersection B equal to B intersection A1?
This one? You want this one or the implication here?
I mean, I'm fine with the implication. I would like to know about this point, the last point.
Okay, let's say A equal to 1, 2, 1, 3, 5. So 1 second. A equal to 1, 3, 5, 8, 9. And B is equal to 1, 5, 8, 3, 0. What is A intersection B?
1, 5, 8.
1, 5 and 3 also.
Yeah, 1, 3, 5. Actually.
Okay, 1, 3, 5, 8. Now see what is B intersection A?
B intersection A is also same, 1, 3, 5, 8.
That's what I meant.
Okay. Okay.
If you are taking common elements, it doesn't make sense which order you are taking common elements.
Okay.
Whether you combine here to here or here to here, Both the ways common elements are same, right?
Yes.
For example, if there is a commonality that you and me smoke together, okay?
Okay.
The common element is you and me smoke. So if you say what is the commonality between Abid and Sandeep versus what is the commonality between Sandeep and Abid, both are same.
Yes, sir.
Similarly, the same thing happens for A union B equal to B union A.
Got it, sir.
Okay,
Mhm.
fine. Anyway, that is not my concern at this point. My concern is understanding what is this conditional probability. Now, what is this conditional probability? I'll solve it again using example. Now that way it will be easier for you. So let's say earlier I tried this example, right? Probability of getting 2. Let's see how probability of getting 2 will change when I do a conditional probability. Let's say probability of getting a 2, given that it is a maybe that's not a right example. Let me give. Okay, that's fine. Probability of getting 2. Let's say if my question is changed to probability of getting 2 given the card is
Spirit.
numbered. Okay, let's say the card is already numbered card, which means it has some numbers on it, right? You already know that whatever card you are picking is a numbered card. Okay, so you don't have to worry about all the 52 cards now. You know that it is already a numbered card, which is how many? Only these 9 into 4, 36. So your sample space is reduced because of the condition that you got. Remember this very carefully. Because the condition is there, your sample space is not 52 now. Your sample space is simply 36. Why is it 36? Because you are already giving that your card is numbered. Since utilizing that condition, you can reduce your sample space from 52 to 36 because you have now lesser number of cards. Now out of that, you are asking for a card which is 2. How many such cards are there?
4.
4. So what you can say, instead of saying earlier what is my answer, it is 4 by 52. Are you clear or not? Initially, when I don't have a condition, when my question is about getting a 2, it is 4 by 52. Now suddenly, because getting a card, I am also saying that given that card is already numbered card, what I am getting? I am getting a lesser number of sample space. The sample space is only 36 now. And out of that, I am asking for 2. So it's only 4 cards. So 4 by 36. Is this point clear? Is this point clear? Why I am reducing the sample space?
Yes, Sandeep.
Yeah, it makes sense for me.
Like we are giving condition means it's like we know that
We know some
Sam-
information actually. Already we know some information. So
It
using
means
that information, we are increasing our probability of getting a success.
yes, by using that information, we are removing some elements from the sample space and we are.
Yes, that's right. So others, I think Abid and Subbu responded. Vijay and Zahir, are you clear?
Yeah, makes sense. I guess a little bit more, few more examples, would be helpful.
Yeah, we'll be going into more examples, but until here, is it clear?
Yeah, I'm fine, Sonia.
Yes.
Yeah. Okay. So let me ask you a few more questions. Let's say probability of getting. We can actually use these to add more conditions. That way you'll get. So getting an even numbered card, given that it's a let's say getting an even numbered card given that it is it is a red card. Okay, even numbered card given it is a red card. How much it is?
Now our sample space is 30. So
30. How is it 30?
13.
I said it is red card.
26 is sample space.
26, right?
26.
Then how many are there for even numbered cards?
10.
10 cards. 10 by 26. 10 by 26, right?
Yes, 10 by
Yeah,
26.
Sorry. 10 by 26. By 26. Now, how do you do that? Again, the same thing. Earlier it is 20 by 52. Now it is 10 by 26. But actually, if you see, these two are same. So sometimes you may get the same number, same probability. But most of the times what happens is your probability will get improved. So for example, in the first case, how much is 4 by 52? Say 4 by 52. If I multiply any probability by 100, I'll get percentage. So this is some 7.6 percentage of probability of getting 2. Now probability of getting a 2, given that card is numbered, is 4 by 36. Again 4 by 36 into 100. It will become 11%. So this is 11%. So sometimes your probability will get increased. In this case, probability gets increased. But in few of the cases, what happens is this 10 by 30. Can you reduce this into 10 by 26? If you cancel by 2, this is 10
Yes, sir.
times, this is 26 times. You can do, right?
Yes.
So sometimes probability remains the same, but it won't get reduced at least. Using the conditional probability will get improved most of the times. Sometimes it may not be getting improved. In very rare cases, it's not very frequent. Is that fine?
Yes, Sandeep.
It is just because your sample space is reduced by 2 times. Your event space is also getting reduced by 2 times, just by chance. Now, let me ask you few more questions. Let me ask Vijaya first this time. Vijaya?
Yes, I'm here.
Probability of a picture, given that it is not a spade. Now, spade is this one. Okay. Spade is the second one.
Sample space is 39.
Uh-huh.
And let me see.
Getting a picture. Sample space is 39. And
answer is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9.
So it is 9. 9 by 39. You're right. Okay, I think you pretty much got what I was saying. But still, I'll give you a few more problems, maybe 1 or 2. Probability of getting a diamond given it is an S. Probability of getting a diamond given it is an S.
Is it 1 by 4?
1 by 4, yeah. Because sample space is reduced to 4. Given it is S means it is only 4 possibilities. So it's 1 by 4. Maybe one more final one. Probability of getting a 3 given a diamond and spade. I'm just using some intersection here. When I say and is nothing but intersection. So probability of getting a 3 given it is a diamond and spade. And this is tricky.
Diamond and spade, we don't have the combination here.
What is diamond? Diamond is all this. Spade is all this. Now diamond and spade, how much is the sample space? 0.
Yes.
Now I said in the denominator, you should use the sample space by 0.
Yes.
How many 3's are there which within that? Again 0. Should I say 0 by 0 which is infinity?
No.
I should not say. Probability is never infinity. When the sample space is 0 itself, call the probability as 0.
Yeah, makes sense.
Okay, because there is no sample space. What is the probability? The sample is not there. Within that, how do you identify events? There is no event.
Yes.
So probability will be 0. Do not say it is 0 by 0 or infinity. You don't say that. Probability is never infinity. Okay.
Okay.
So Sandeep, if it was just diamond, 3 by diamond, it would be just 1 by 13, right?
Yeah, if it is only diamond, then it will be 1 by 13. Yes.
Okay.
But if
So
it
just
is
because you got the intersection, that's when it negates it.
exactly, yeah, that's right. But instead, let's say, maybe I'll give this one also, just a variation of this. Diamond union spade. What happens?
2 by 26.
2 by 26.
Yes, there are 26 sample space, out of which there are twos, right? Twos or threes? Threes. 2 threes. 2 by 26. Right? Hope you are getting what I was saying. So any questions till now? So I'm going to close this conditional probability also. Now that you learned how to do this. Have
Yeah,
time.
good, Sandeep.
Okay. You should be very clear about these probabilities so that you know tomorrow when I start inferential statistics, you should be okay with probability. When I say probability, you should be able to grasp what is probability at least. And the second thing is, this is not just used in inferential statistics. This is also used in the entire course. Especially, there is a theory called Bayes' theorem. I don't remember the spelling exactly. Bayes' theorem. So, in Bayes' theorem, conditional probability is the only thing we will use. Without that, there is no Bayes' theorem. So, all this fit together. Okay. So there is one last concept I want to just mention. Mutually exclusive. Now what is mutually exclusive? By the way, I have not used the formula, right? Let me teach that. I'm just using this conditional probability. I'm just reducing the sample space and trying to give you the final result. But without this, I can use this formula also and try to solve the problems. Sorry for that, I missed it. So I can just use this formula without reducing the sample space also. I can solve the problems. Let me show that also. Sorry for that. So I can use the formula. How do I use? I can say probability of getting a 2. If I use the formula, getting 2 and or intersection and an intersection, both are same. And card is numbered by probability that the denominator will contain the condition. That's what I said, right? Probability that card is numbered. This is the formula. Now,
Yes, sir.
now in this, I can say probability of getting 2 and card is numbered. Let's see how it goes. Probability of getting a 2. This is the event space for, yeah, this is the event space for it. Probability of getting a numbered card. Numbered card are all these 36. I am doing an intersection. Intersection will become 4. So
4 by 36.
probability of getting a 2 and a numbered card will become 4 by 52. Here there is no condition. So do not reduce the sample space in the numerator or denominator, okay? After
Yes, sir.
using the formula. So it will become 4 by 52 by, what is
36
the
by
card is numbered? 39, sorry,
36.
36 by 52. These two will get cancelled. It will become 4 by 36. So whether you reduce the sample space and directly write the answer, or if you use the formula and use the, try to find the answer, both will be same. Only thing is this denominators will get cancelled here if you use the formula. Are you clear?
Yes, sir.
Others?
Yeah, it's clear.
Fine, Sandeep.
It's more like here also, if you use the formula, it will become 10 by 52 by 26 by 52. Even here, 9 by 52 by 39 by 52. That's how you get it. So I just gave you an easier way to solve the problem. But if you cannot remember that, you remember the formula and try it. It's easy. So that is about the probability, conditional probability. Now, sorry, one second. There is another thing, another important thing actually. Today we are going to close the probability actually. Independence. So what is independence? So when you do conditional probability, so if the condition is independent of what you're doing here, then it is called independent events. So for example, probability of getting a red card, given that today is holiday. So does holiday affect your probability of getting red card? No. These two are independent events. This event is completely different from this event. So it's not going, this event, this condition is not going to affect this probability. So what happens is, when you do have this kind of a this kind of an independent events, where one event is not the condition is not affecting the probability of another event, what happens? It is same as probability of red card. you can just ignore the condition and write probability of red card, because these two are independent. There is no reason why this should affect your probability of getting a red card. So how much it will be? 26 by 52. There is no difference. Now, what I am saying is probability of A given B is nothing but probability of A. The B is gone. Now, if you use the formula, in the formula I mentioned that probability of A intersection B by probability of B is equal to probability of A. This is what I mentioned. So I tried to substitute the formula and try to substitute it in the equation. Now, if I want to find out what is probability of A intersection B, I can move this to other side, cross multiply probability of A into probability of B. When A and B are independent events, probability of A intersection B is nothing but probability of A into probability of B. And this is one of the most important things that we'll be using over and over together. Okay, when A and B are independent events, probability of A intersection B is nothing but probability of A into probability of B. Is that clear?
Yes, Sandeep.
Yes, Sandeep.
Okay. Now the final thing in probability, or I'll discuss this tomorrow. Let's park it here, and this is the final topic in probability. That's fine. We'll see it later. So we'll have a break of 5 minutes. 7:33 we'll come back. We'll see some Python scripts today. Is that fine?
Sure, Sandeep.
Fine,
Okay. Okay, thank you. We'll come back at 7:33 exactly. Hi, is everyone back?
Yeah, I'm here.
Yeah, yes, Sandeep.
Yes,
Okay,
Sandeep.
cool. Yeah. So we'll stop the probability for now, and we'll try to see some Python scripts. You know, for you to understand some of the intricacies of Python, we want to do a few sessions on Python. So every day we'll try to stop at 7:30 or something. Last half an hour we'll try to utilize for Python. That way we'll get used to Python. Okay. Now I want you to download. One second. I have also already posted one Python script to you on whatever link I shared. So in OneDrive, you can see here. This is your drive, and here you'll see data sets as a one folder. Another folder will be Python. So you copy this Python script into your machine in some location, whichever location you prefer, that is fine. But make it accessible to your directories. So keep it in some accessible location, better place. So once you do that, let me know. In the meantime, you can also open your terminal or any command prompt. In Mac, it will be called terminal, and command prompt in Windows. Type Jupyter Notebook. See this command very clearly. Jupyter, Jupyter, and notebook. Jupyter space notebook, and enter. So you'll see this kind of a UI. So once you download the file and open the Jupyter Notebook in browser, please let me know. I'm giving you 2 more minutes. 7:38.
I got it.
You're able to do? Jupyter Notebook is open?
Yeah.
And are you able to copy somewhere
Yes.
in your machine? Okay, cool. Others? So you're going to do this initial setup over and over again every day. So whenever I post anything in that directory, just keep it in your wherever whichever directory you did now. Always use the same directory. Abid, you did not get link. I asked many times, you did not respond. Let me give you that now. Not this one. I need something else. Office, yeah. Can you give me your email ID, Abid? Okay, I'm sharing you right now. Please download that Python file.
Sure, Sandeep. Thank you.
You should get a link now.
Yeah, I got it, Sandeep.
You got it, right? Okay. Download that Python file. There is a folder called Python. Download that Python file. Put it in some directory. And always use the same directory from now to access these Python scripts so that it will be quicker for you
Sure.
in the class. Are you guys able to do? Everyone?
Yes, Sandeep.
Okay.
Yeah, I downloaded. Just putting it in a folder. Something.
Okay. Put it in some accessible folder. And remember, there is a one problem with Jupyter notebooks. When you open in one directory, you cannot go a directory previous to that. So once you open this in Jupyter, so I'm in some directory, right? I cannot go one level up. So wherever you're running the Jupyter notebook, ensure that it is not before that directory. What I mean to say is you cannot go one level up. You can go only into the directories. Are you able to do, all of you?
Yes.
And please
Yes,
remember these steps. Every day we are going to do this step of copying the Python file and running the Jupyter notebook almost every day. So from tomorrow, I'm going to say just copy it into your directory and open Jupyter notebook. You should be able to do. Now, once you are in this Jupyter directory, I mean this UI, you can just browse through. So for example, all these are my directories, whatever I have on my local machine. So for example, I can go into this R tutorial, anything I can go into. And here I can go back. Okay, that's how I can navigate. So in my directory, it is in Python and not here. Let me go into your drive, OneDrive, notebooks, and this Jan 2018, which is your batch. I will see this Python directory. I'm going into the Python. So here I can just click on this Python notebook. I am now just navigating into the directories and I can see this Python notebook. I can just click on it. So when I click on it, I can see the entire Python notebook and some commands inside. Are you able to come until here?
Yes.
Others?
Yes, Sandeep.
Sandeep, I think I put it in my D drive. I'm not able to view that in the notebooks. Let me change it.
Yeah, when you type this, that's what I reminded you. When you type this Jupyter notebook, keep that notebook in an accessible location. Yeah, you can do that now, probably. First time it happens generally.
Yeah, I'm able to open that Python script file in Jupyter notebook right now, Sandeep.
Okay, very good. Yeah. Let's wait for Zahir then. A few minutes.
What exactly is this Jupyter notebook?
Yeah, I'll let you know in a minute actually. Let Zahir come up to speed.
Okay.
We'll discuss together.
All right, Sandeep, I'm good. I get this.
You're able to open the notebook?
Yeah, I moved it to my C drive, then brought the folder to desktop.
Okay, cool. So everyone is on the same page right now, right? So now, so what is this Jupyter notebook and all? So this Jupyter notebook, whenever you run this Jupyter notebook command, it actually runs a server inside your local, and it creates this kind of a UI. And this UI is useful for all the data scientists. Actually, data scientists run their regular code, day-to-day code in this Jupyter notebooks. And the reason is, you can see here, there are some sections. I wrote I gave some titles. This is more like a notes than a coding environment. That is the reason why most of the data scientists use this, and they share across this to other data scientists also. So for example, today you did some analysis on your laptop, like the way I shared you the IPython notebook. Data scientists generally share these notebooks to other data scientists or their managers to get their analysis reviewed, or to get more insights to the analysis. So this is more like a sharing environment across the data scientists. That is one thing. Another thing is, I can write everything in a single place with all the comments also. So this is a comment actually. What I wrote here, Python language basics 1, part 1. This is nothing but a comment that I wrote. And that comment looks like a simple text. It looks like my wiki page. So that is another reason why we use this Jupyter notebooks. So it's very easy to find out. And second thing is, if I want to write some code, all I can do is I can create a cell like this, one cell like this, and inside the cell I can go and type. Is that fine? That's how Jupyter notebook works. So for example,
Yes.
I can just do 8 plus 9. It's more like your calculator also. Or I can do some more advanced things like doing for loop or if conditions or anything like that. All your code will go into each of these cells, and you can run each cell independently also. So for example, I did not run any of the cells above, but I can run this cell. Only this cell I can run. When I am running the cell, I am pressing shift and enter. When I do shift and enter, the the answer will be coming after the cell. So it's very easy to use programming environment, as well as it will become, once you create all the programming constructs and everything, it will finally become your notes also. It's both the way. Is that clear?
Yeah.
Yes, Sandeep.
So we'll try to create a new notes as well, but for now today we'll try to use the existing notes. So here in the menu, you can see there is a all output, current outputs, all these things, right? You can go and clear the outputs. If you see here, I already ran 8 plus 9, which is 17. But let's say I want to clear the outputs. I go here and clear. It will reset all the outputs wherever it is there. So earlier I ran here also. So those kind of features are there. Let's see how Python works first now. For now, then during the process we'll learn how Jupyter works as well. Is that fine? So first thing is, I wrote some comment here, and this is embedded with hashes. Actually, hashes in Jupyter, it will give you comments, as well as it will it will make this as a bold text. If you see here, it is a very bold text. So to do these kind of things, in this drop down, in the above, you can see there is a drop down here. So there are two important things that you want to use majorly. One is code, another is markdown. When I say a cell is marked down, it means that that cell is not usable for coding. The code will not get executed. Whatever is there in the cell, it is displayed. And here I am using a markdown called hash, which will give me the bold text. Now, if I want to decrease the size of this boldness, I can add more hashes. Okay, the more hashes that I add, the less the size of the text will get reduced. Now I'm using only one hash. It is becoming very large. What if I don't use hash at all? It will become a plain text. That's how markdown will work. Markdown is more like your notes. Is that fine?
Where was that markdown again?
So it is above here in this title bar. You can see
Yeah,
here.
I see. Do you press that before or after we type whatever we need to type?
Okay, whenever you want to create a cell, you can use this plus button. When you get a cell, generally it will be by default code. But if you want to make it by markdown like this, convert it into markdown, then you can type. Okay. And once you type, it is in still blue, right? You have to press shift and enter. Only then it will become this kind of, text. Otherwise it will be like this. Is that okay? Are you able to do that now? So most of the times I want you to do along with me, but I cannot wait for indefinitely. So I would suggest, if you cannot follow me in the class, I would suggest you to go back and practice this and come back with questions. That is also fine. So that's how I can do this, markdown. But most of my cells will be code. So that is also one thing that I should use. So when I do a coding section, the code inside this cell will get executed. So all these are code sections until here, all this. So let me show you how it works. So whenever you write any code, you press again the same thing, shift and enter. It will execute and go to the next cell. But if you want to insert one more cell, execute this cell, and after executing, if you want to run create a new empty cell, what you have to do is control and enter. Sorry, not control and enter. Alt and enter. If you do alt and enter, it will add a new cell, execute the current cell and create a new cell. Is that fine?
Sandeep.
Okay.
Yeah.
Now let's go into, I think you got enough Jupyter knowledge. We'll go through Jupyter whenever we need anything on Jupyter. We'll not
Quick
describe Jupyter much. Sorry?
How did you delete the cell?
There is cut cells. I can remove from here. So any cell, for example, alt and enter, if I add empty cell, any cell can be deleted by selecting the cell and this one, this cut cells, it will go. Okay. Now let's go into Python more than Jupyter for now. We'll see whenever we need anything, we'll come back to Jupyter and understand. Because Jupyter is not what we are interested in actually. So in Python, there are different literals. When I say literal is something like a number or some basic data type, some basic element in the Python. So for example, if I say 5 is a literal. But this is called an integer literal because it is an integer, which means it doesn't have any decimal points. Python also have, if I do control enter, like I said earlier, I'll execute that cell and come to the next cell. Python also has this kind of literal where it is decimal literals. When I do 2.5 is a decimal or floating point. In most of the languages, you'll have floating points. So here it is a floating point literal. Again, if I do shift and enter, it will return the same element. The output is the output of whatever you run here will be shown here after the cell when you execute. So you have integer literals, you have floating point literals, and you can do some operations on this. For example, I am doing 8 plus 9. It's simple calculation, and Python immediately returns with the number that after adding how much it will be. Okay. Similarly, you can do multiplication also. Maybe instead of 1 into 3, maybe if I do 5 into 3, it still does multiplication. And multiplication here, the operator is star. It's not cross. Do not use cross. Cross is X in Python. Now you can do bigger calculations as well. You can do 25 plus 3 into 6. Now the question is, how is the order of evaluation happening? It may be 25 plus 3 into 6, or it may be 3 into 6 plus 25. Now in Python, generally in most of the languages as well, into will have higher precedence. So multiplication will happen first and then 25 will be added later. Okay, so it will be 25 plus 18, which comes to 43 in this case. But in some cases, what you want is maybe you want addition first and then multiplication. This order of this is called associativity, and association happens first with multiplication. But if you want to change the association first with plus instead of multiplication, what you can do is you can add this kind of a brackets. This set of brackets are called parentheses. In most of the programming languages, this is there. If you use this parenthesis, plus will happen first and multiplication will happen later. Notice that these two are exactly the same, except that you have an additional set of parentheses. So if I execute here, you can see that the value changes just because of this parenthesis. The reason is it is doing 28 into 6 instead of doing 18 plus 25 plus 18. So the value changes. So be very careful where to use these brackets or called parentheses. Based on where you use parentheses, the order of evaluation will change. Now the final thing in the literals is string literals. Actually, you can use strings in different ways. When I say string is nothing but a sequence of characters. It's not a number. It's something like a text. So the text you can only use within double quotes. You cannot use single. You can use either double quotes or single quotes to enclose the literal. So if I execute this, it will run. But if I say just a Python without using any quotes and say shift enter, it will say name is not found. It is trying to identify this as a name that Python knows, and Python doesn't know the name called Python, and it is failing. So whenever you are using any string, any textual data, always enclose it with quotes. One way to enclose is double quotes, and another way to enclose the strings are single quotes. Both are same. If you see, the output is saying both single quote Python. So both are same. But if you don't use quote like this, hello, let's say, if I do like this, it will try to identify this name with whatever names that Python knows. And Python doesn't know the name called hello, so it fails. So always do use quotes whenever you want to use a string. And there is another way of using a string, which is called multi-line string. When you want to use a multi-line string, all it has is 3 quotes together. When you use 3 double quotes together, you can write as many lines as you want. It doesn't matter. Okay. If you execute this, it will still give you a string. I mean, an output. It doesn't fail in fail saying that I cannot find the name or some other error. But if you use the same thing, let me show you here. Alt enter. If I do alt enter, I'll get another cell. Instead of using double quotes, if I do single quote, what happens? If I do again shift enter, it will fail. It is saying end of line while scanning the string. It is trying to scan the string. It encountered an end of line, but it did not see this ending quote. If it did not see the ending quote and it is a single quote, it will say that it cannot process that string. So any multi-line comments and any multi-line strings, you have to enclose with 3 quotes, 3 double quotes. Is that fine? Are you able to follow until here? The literal part. So there are, in short, there are 3 literals. Actually, many more literals, but until now, what we covered is integer literal, floating point literal, and string literal. And string can be of 3 types. Either it can be double quotes or single quotes or 3 quotes. Single and double are almost same, but 3 quotes, 3 double quotes, if you use, you can use multi-line strings.
What is the /n between the?
/n is nothing but the new line. Here there is a new line, right? After this there is a line, and then in the new line you have another string, and then you have another line. So every time you encounter a line, there is a new line, you see a /n. At the end of this line, you'll see /n. At the end of this line, again, you see /n. Again, here, after multiple, you'll see /n. And finally, there is no /n because there is no new line after this. Is that fine, Vijay?
Yeah.
Okay. Any questions till now?
And I guess instead of double quotes, we can use single quotes as well, correct?
Yes,
Like 3.
you can, yeah. So I did not include one more thing. There is a Boolean literal, which is only either true or false. These are the only 2 types that are there in the Boolean literal. Let me add to your notes. Okay. So there is a Boolean literal. When something is true, you can say true. When something is false, you can say false. These 2 values are related to Boolean literal. So in short, you have integer literal, floating point literal, string literal, and finally Boolean literal. Are you clear so far?
Yes, Sandeep.
Okay.
Yeah, yes, Sandeep.
Now you can also see these data types, whatever I said, Boolean, integer, these are called data types. So each literal will have different type. So for example, if I say type of 5, it will say integer because this is an integer literal. If you say type of 2.5, it should say float because it is a floating point literal. Similarly, if I do for strings, it should say str. If I do for true, it should say Boolean literal. Similarly, if I do for false also, it will become a Boolean literal. What it means is it is a type. This literal is of type Boolean. This literal is of type string. This literal is of type float, and this is of type int. 5 is of type int. Now, what if I do a multi-line string? It will still say it is a string literal. Okay, every data point that you enter into the Python will implicitly have some data type, whether it is a 5 or 2.5 or Python or anything. Everything will have type. If you enclose it with type function, there is a function called type. We'll go into functions later, but to call a function, it is simple. It is as simple as name the function, give the parenthesis. Inside that parenthesis, you give some arguments. That function will get executed. In this case, we are using the type function, which is a default function built into the Python. Are you fine with this until here? Data types? Okay.
Yes, Sandeep. It's good.
Okay. So we'll complete the operators and then close. So we have many operators in Python, but primarily we'll use plus, minus, into, and all. So now this is a plus. So 2 plus 5, it will just output you the outcome of the 2 plus 5, which is 7. For doing multiplication, you should use star, like I said earlier. It's okay if you do like this also, but generally for any operator, for me, it is better to keep a space at both the places. It's not for any coding purpose, it is only for your viewability. This looks much better compared to this, as simple as that. So that's why I generally add spaces before the operator as well as after the operator. Is more like a coding standard than anything else. So if I use star, it will multiply the things, and if I do a minus, it will subtract. 2 minus 5 will become minus 3. Now mind you, minus 3, which type is it? Minus 3 will become still an integer. Okay, anytime you don't see a point, decimal point, you can safely assume that it is a integer data type. Now there is a division operator finally. Now this division operator is a little bit tricky. Generally 1 by 2, you can still use the spaces at both the places. I mean before and after. Normally 1 by 2, we assume that it is a 0.5, 0.5. But in Python, if you use 1 by 2 like this and do shift enter, you'll get a 0. The reason is 1 is an integer and 2 is also an integer. So when we are performing an integer division, Python will expect the output to be also an integer. Now if if we do 1 by 2, 1 by 2 is 0.5, and 0.5 is actually decimal point. I mean it's a floating number. When you do an integer division, you cannot expect a floating point number. In Python you will get only a decimal number, integer number. So that's why instead of 0.5, it stripped off that 0.5 and gave you only 0. Now what if you want to do a floating point division for this 1 by 2? To do that, you have to use this float function. If you use this float of 1 by 2, what Python will assume is this is a floating point number and it will divide it by 2. Now you will get 0.5. Is this fine? Whenever you are doing division with two integer numbers, one of them at least you keep enclosed with float, just like you enclose this with type. Float is another function. We'll go to functions, but this is something that is needed at this point. Hope this is clear. Now,
Sandeep, if you do 1 divided by 2.0, what happens?
I can also do that, yes. But there 1 by 2.0 means 2.0 is what? It's already floating point number.
Yeah.
If one of them is already floating point number, it will easily give you the answer. But in this case, both are integers. That's why it could not give you 0.5.
Okay.
Now, if you still want to use 1, but still get this one, 0.5, that's where you should enclose it with one float. Okay. Now,
Yes,
yeah, anyways, I hear you're right on what you said. Now, if you want division, in division, you'll have reminders and quotients. When you do an integer division, for example, 4 by 3, and shift enter. When you do any, instead of 4 by 3, let's say 8 by 3. Okay. When you do an integer division, all you get is a quotient. This is called quotient because you can do 3 times of 2 times of 3 is 6. You are still reminded with, your reminder is 2. So you are only getting quotient when you are doing a integer division. Now what about the remainder? Remainder part you can do with percentage. This percent symbol will give you the remainder. So if I do 8 mod 3, you will get 2, which is also a remainder. So when you do a slash with integer division, it is going to be a quotient. The percentage will give you the remainder. Maybe I should use a bigger number. Maybe let's say 14. 14 is giving me the 4 as my quotient because 3 4s are 12. And there is a remainder of 2. So here if I do 14 mod 3, I'll get 2 as a remainder. Then again, if I want to do a power operation, there is an interesting operator here, which is double star. If I do like this, it will become 2 power 4 and it will give you 16. I can do any power. For example, 5 power 4. I get 5 power 4 as 625. Any kind of powers I can do here. Now the next one is what I have already mentioned. If I do 2 plus 3 into 5 plus 5, in this entire evaluation, 3 into 5 will happen first. It will become 15. 15 plus 5, 20. 20 plus 2, 22. It will become 22 here. But if I want 2 plus 3 first and 5 plus 5 first, and then multiply those, I have to use this brackets. Now it will become 5 into 10. It will become 50. And on strings, the only operation you can do, I have mentioned how to do operations on integers and all. But on strings, there is only one operation. That operation is concatenation. When you want to combine this string with this string and this string, you can use a plus operator again. And this plus operator will concatenate all of this into single string, one string. So all of this is becoming welcome to data science class. Okay, any questions till now? I think I'm overbooking by 13 minutes already.
No, I'm good, Sandeep.
Sounds good.
Good, Sandeep. Fine.
Okay, we'll park it here. We'll discuss the rest tomorrow. maybe on Monday. Monday for people from India and Sunday evening for others.
Sure, Chandra.
Okay.
Sure, Sandeep. Sure.
Okay then. We'll catch up on next class.
Okay.
Bye.
Mm.